Okay, here we go. We're looking at section 9.7, the cross product between vectors. Now, this is only for dealing with three-dimensional vectors. So that's the first thing you need to know. And what a cross product does is unlike a dot product, a cross product gives us another vector, and that vector is going to be perpendicular. That's what orthogonal means. It's perpendicular to the two vectors we started with. So if I had vector A and vector B, the cross product of them is going to be this vector, which is perpendicular to each of them. So notice the little perpendicular symbols there. And the way we write cross product is with the x between the two vectors. So this is A cross B. So how do we do that? How do we find it? So here is our formula of how we go about finding this. So if I want to look at V cross W, the B component from the first vector times the C component of the second vector minus the B component of the first times the C component of the first, multiplied by the unit vector in the x direction, minus, okay, so minus the x component in the first vector times the z component in the second vector, minus the a component or the x component in the second vector times the z component from the first, plus, okay, the x component from the first times the y component from the second minus the x component from the second times the y component from the first. That looks like really complicated, but let's go through it so it makes a bit more sense. So our I coefficient, I'm going to take 5 times 1 and negative 2 times negative 2. So those are my I coefficients. The j component, again, remember we're subtracting. The formula has a minus sign in it. A1, so that's a 3, times C2, that's a 1, minus A2, negative 2, times C1 is a negative 2, plus, times the j unit vector, plus the A component from 1 times the B component from the second, negative 2, minus A2, so that's from our second vector, the A component, negative 2, times B1 from the first vector, the coefficient of j, which is a 5. So now we're just doing mathematical, arithmetic stuff. 5, I've got 3 negatives there, so I can stay negative, 4. So 5 minus 4 times unit vector I, that's 1I, minus 3 minus 4, that's a negative 1, but I'm subtracting it, so it's a positive. And finally, negative 6 plus 10 gives me a positive 4 times k. That is the vector that is perpendicular to both of these vectors, v and w. That looks really intimidating, and I'm going to show you an easier way to do this. And that's using what's called a matrix. And determinants is something we get from a matrix. So if I were to write my vector in order, so let's take a look here. If this is vector v and this is vector w here, these are the coefficients for I, j, k from vector w. The way we write this now, and let's go ahead and do this, I, j, k, lowercase ones. If I'm looking for the coefficient of a, I'm going to multiply a1 times b2 minus b1 times a2. Actually, that's backwards, sorry. If I'm looking for the coefficient of a, I don't use the a, excuse me. So if I'm looking for my coefficient for the I, I'm going to look b1 times c2 minus C1 times B2. So that's in green. If I want the coefficient for J, I'm going to take the first, so I'm not using this middle one. So I'm multiplying A1 times C2 minus C1 times A2. And finally, if I'm looking for the coefficient of K, I don't use that column, and I have A1 times B2 times B1 minus A2. So let's take a look at this, how it works. Okay, so let's take a look at this. So we'll start just doing a 2 by 2 matrix. The determinant is going to be multiplying things on the diagonal, so negative 1 times 1 minus things going in the opposite diagonal, 4 times 6. So negative 1 times 1 minus 4 times 6. So we get a value of negative 25. If I want to find the determinant of this 3 by 3 matrix, if I'm looking for the first one, I'm going to have 2 times 1 minus 3 times 2 multiplied by A. To find the coefficient for the B term, I'm going to be subtracting. And again, we pretend like the B one's not there. So 1 times 1 minus 3 times 4 multiplied by B. The last one, the C, again, I don't use this column. 1 times 2 minus 2 times 4. There we go, multiplied by C. So when we do the arithmetic here, we have a negative 4 times A. We've got a negative 11 minus, so that's plus B. And 2 minus 8 is a negative 6 times C. So the key is cover up the one that you're looking for, and then multiply starting from the upper left to the lower right, and subtract upper right towards the lower left side. So let's try this. I know it seems very strange, but let's put it into practice here. So we've got these two vectors, v and w, and we are trying to find the vector that is perpendicular to both of them. So let's take a look here. V cross w. So I write I, J, K across the top, so my unit vectors in each direction. V was my first vector, so I've got to put that as my second row, all the coefficients, 2, minus 3, and minus 2. W is the second vector, so I put its coefficients, 4, negative 1, 5. And now I want to find that orthogonal vector, the result of V cross W. So looking for the I, negative 3 times 5 minus negative 2 times negative 1. Minus, I'm now going to look for the coefficient for J direction, cover up the J, 2 times 5 minus 4 times negative 2. And finally, the coefficient for K, 2 times negative 1 times negative 3, or minus a negative 3 times 4. And there is my resulting orthogonal vector. Now we're going to do the same thing, but this time we're reversing the order to see what impact that has. So vector W cross vector V. I have to list the coefficients for vector W in the middle row and vector V in the bottom row because of the order we're crossing them. And again, coefficient for I is negative 1 times negative 2 minus 5 times negative 3 times I minus, we're now looking for the J coefficient, so 4 times negative 2 minus 5 times 2. And finally, coefficient of K, I cover up the K column, 4 times 3 times a negative 1 times 2. And look at this vector. Notice the difference here. We had a negative, here's a positive, negative, positive, positive, negative. So if we reverse the order that we cross these vectors, then the resultant vector looks the same but with opposite signs. So it's going in the opposite direction as the first cross product. What happens if we cross a vector with itself? So Write that down. And again, covering the column we want, -3 times -2 minus a -2 times -3. Going through all three of them, we get 0. The coefficients for every single thing is 0. Likewise, if we cross W with itself, we get a vector of 0. There is no vector. And this is something that will happen. Anytime you cross a vector with itself, the result is simply 0. Okay, and continuing on, we have some algebraic properties here. If you cross a vector with itself, the result is 0. If you cross a vector in the order of u times v, and then reverse the way you did the cross, so v times u, it is simply the original one with a negative in front of it. Okay, if you have a cross product multiplied by some scalar value, you would just distribute that. So you distribute a to vector u, or you distribute scalar a to vector v. Likewise, we can add two vectors together and then cross them with u. You would have to distribute here, u cross v plus u cross w. Some geometric properties from the cross product. U cross v, by definition, is the vector that is orthogonal or perpendicular, remember, perpendicular to both vector u and vector w, or vector u and vector v. The magnitude of the cross product of them is equal to the magnitude of u multiplied by the magnitude of vector v times the sine of angle theta. And angle theta is the angle between these two vectors. The magnitude of vector u cross vector v, the value you get there is the area of the parallelogram, provided that vector u is not 0 and vector v is not 0, and that u and v are adjacent to each other. They're not parallel to each other. Okay, the other geometric property is that vector u cross vector v equals 0 if and only if those two vectors are parallel. Okay, so let's see how we can use some of these properties. So I want to first of all find a vector perpendicular to vector u and vector v. So that means I need to find the cross product of these two vectors. So I'm going to say u cross v, and again we're I, j, k. I write vector u's coefficients down first, then vector v's. And again, if I'm looking for the coefficient of I, it's -3 times -4 minus 2 times 2, minus, we always have that minus in there, looking for the j coefficients, 4 times -4 minus +2 times -1, right there. And the coefficient for k, 4 times 2 multiplied by, or subtract a -3 times -1. So this is the vector that is perpendicular to both u and v. If I want to check that, so this vector, if I do the dot product of this with vector u, I should get 0, because by definition, this vector is perpendicular to the cross product. So I'm looking at vector u dot the dot product, vector u dot the orthogonal vector I got by finding the cross product. So here we go. So this is really u dot, if I had to give this a letter, maybe we could call this w. It usually doesn't get a letter, but that is w right there. And we got 0. We should also check that it is orthogonal with vector v, because again, by definition, this should be orthogonal with both u and v. So vector v dot that vector w, the one we got from the dot product, or from the cross product, and again, we get 0. And remember, we said by definition, the area that we get from doing the cross product of two vectors is the area of the parallelogram. So if I've got these two, well, I'm giving us 4 points here. 0, 0, 0, 3, negative 2, 1. Point 3 is here, and point 4 is here. This is basically a parallelogram in 3D space. So I'm going to define vector u as going from point 1 to point 2. So that's one side of the parallelogram. I have to find the vector u, and I find it by taking the x value from P2 minus the x value from point 1. The j component is negative 2 minus 0 times j, and 1 minus 0 times the k unit vector. So this is vector u. Vector v, I'm defining, it has to start at the same point as this one, so point 1, and I'm going to go to point 3. So here we again are taking point 3 minus point 1, and this is the vector I get for v. So now I have these two vectors defined. If I take the cross product of these two vectors, I will find the area of the parallelogram defined by points 1, 2, 3, and 4. So here is coefficients from vector v, coefficients from vector u and v. Again, we are going to find the determinant multiplied by the unit vector in the x direction, y direction, z direction. So here is the orthogonal vector to u and v. But if I take the magnitude of this, I will have the area of my parallelogram. So now that I've got this vector, I'm going to take the magnitude. So negative 1 squared plus 2 squared plus 7 squared, square rooted. The area of this parallelogram is approximately 7.348 square units, whatever those units are. And let's do another one. This time it's just a little bit different. And I'm trying to find the volume of this parallelepiped. So, a little different. But what I'm going to do is cross vectors A and B, which gives me the area. Okay, so that's going to give me the area of this parallelogram, which is the base of this shape. I am then going to do a dot product with C, because C tells me how far up I go. So it's basically A cross B gives me the area of the base. C is almost like the height, you could think of it. So that's the way we're going to approach this. So the first thing I've got to do is A cross B. So here we go. I've got to find, let's see, here we go. Okay, so here we go. Vector A I've got defined here. And notice the little triangle things around it. Again, that's just another way of writing a vector without having to write the unit vectors of I, j, and k. So I write the coefficients down for A and for B. Again, we're going to do that cross product. So if I want the coefficient of I, it's 0 times negative 8 minus 6 times 3. For J, cover up the J, 1 times negative 8 minus 2 times 6. And again, that is going to be subtracted because our J component always gets subtracted. And then K is 1 times 3 minus 0 times 2. And notice I made a little mistake here. 0 times negative 8 is 0. And then minus 6 times 3 is negative 18. I plus 20j plus 3k. To get the volume, I now take that vector and dot it with vector C. So again, I've got my cross product that I'm going to do a dot product with vector C. Remember, dot product is simply the negative 18 times 8 plus 20 times negative 5 plus 3 times 6. And that gives us a value of negative 226. Well, hopefully you're saying, well, wait now, I thought volumes couldn't be negative, and they can't. Volumes must be positive, so we take the absolute value. So this is 226 cubic units, whatever they are. So to get a volume for this parallelepiped pipette is you take the cross product of any two of the vectors, and then that resulting vector, you're going to take a dot product with the third vector, and then take the absolute value of that. Okay, good luck. And just be careful with negatives. That's the only thing that tends to catch people up here. Okay, you've got this.